Okay, guys, let's talk about Lewis structures, and let's talk about how to write them for covalent compounds. Now, with ionic, we just showed the transferring of electrons. With covalent, it's a little bit different because they're going to be sharing. Okay, we have to pay a lot more attention to the octet rule and everything else. So, we're going to do two examples. The first example that we are going to do is sulfur dioxide. Okay, the first thing we have to do anytime we're doing a Lewis structure is we have to count the number of valence electrons. So when we're doing this, we know that we have a sulfur and an oxygen atom. We have one sulfur and two oxygens, and then we multiply them by the number of valence electrons. We know that sulfur is going to have 6 and oxygen is going to have 6. And we multiply them up, and we get 6 and 12. We add them together, and we get a total number of 18 valence electrons that we're working with. Okay, the next thing we do is we put a central atom. Now, normally the very first element in the formula is going to be the central atom. Remember that carbon is always a central atom. Hydrogen is never a central atom. But if we don't have carbon and we don't have hydrogen and go off, use the first one. And it's usually the one that's by itself. Okay, so we put sulfur in the middle, and then we're just going to put oxygen and oxygen around it. Now, the next step we do is we bond. Okay, now those lines are called, those are shared or bonded pairs of electrons. They're a pair, so they count as 2. So we have 1, 2, 3, 4. So out of our 18, we've already lost 4, so now we're down to 14. Okay, the next step of what we do is we just put them on the outside. Always start with the outside and go to the middle. Now, if we're just looking at this oxygen right here, it already has 2, so it can only take 6 more. So I'm going to put 6 on that oxygen. That took care of another 6. So now I am down to 8. Okay. Now this oxygen, it already has 2, so it can only take 6 more. Do the same thing. We get that, and now we're down to 2. Now, once we have leftovers and all the guys on the outside have all 8 that they need, we then put it on the central atom. 1, 2. Okay. And then we check and make sure, is everybody okay? Okay. We know that the oxygens are okay. They have 8. They have 8 right there. Okay, but when we look, we see that the sulfur does not. Okay, so what we need to do is we need to take 2 guys right here and create a double bond. Okay, now you could be asking yourself, why didn't we take the 2 from right here? Well, you could. You can take it from either side. Sulfur dioxide is actually what we call a resonance structure. So you can take them from here, or you can take them from here. It can have 2 different possible Lewis structures. But this, either way, if we have the double bond here or there, that's going to be our Lewis structure for sulfur dioxide. Okay, let's do one more example. And that is going to be of CH4. This is methane. Okay, so same thing, same process. Carbon, we have 1 of them. It has 4 valence electrons. Hydrogen, we have 4 of them, but it has 1 valence electron per hydrogen, so a total of 4. So in this methane molecule, we have 8 valence electrons to work with. We put carbon in the middle because it always goes in the middle, and hydrogen never goes in the middle, and we go hydrogen, 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 hydrogen. And then we bond. Remember, each one of those lines represents, and that's kind of squiggly, but that's only one line. Each one of those lines represents 2. So 2, 4, 6, 8. We don't have any left. No, I don't know why it's doing that. But what we do from here is we check, and we see that hydrogen only has 2. But since hydrogen follows the duet rule, it only needs 2. And we see carbon in the middle, and it has 8. It agrees with the octet rule. So everybody's happy because hydrogen has 2, carbon has 8.